All right, so this is normal distribution day 2. And a data value x can be standardized by finding its z-score. So sometimes when things don't fall on standard deviations like they did in the last one, we want to be able to figure out how to compare them and where they are. And so we use a z-score, which is your value minus the mean, that's what that little u is, that's mu, divided by the standard deviation. And so we can kind of standardize things by using that. So we have this example. It says, suppose the heights in inches of all women are 20 to 29 in the U.S. are normally distributed, so it still has to be normally distributed, with a mean of 64.1 and a standard deviation of 2.75. Find the percent of women who are no more than 65 inches tall and the probability that a randomly chosen woman is between 60 inches and 63. So we actually want to use z-scores here because if we look and we do a quick little test, if we just look at this and we look at our normal distribution, this 64.1 would be in the middle, and if I add my values, which means I'm going to add the standard deviation to the mean, so 2.75 plus your 64.1, I get 66.85, and if I do it again and add that 2.75 again, I get 69.6, and then again, this gives me the 72.35. Now notice, nowhere in here do I hit 63, okay, or 65. It's in between my standard deviations. If I go backwards and I take 64.1 and I subtract the 2.75, I get the 61.35. And again, if I subtract the 2.75, I get the 58.6. So nowhere on here am I hitting those values that they want me to find. They want me to find at 65 inches and at 60, between 60 and 63. And that's not here. So we can't use the normal curve like we've been using. We have to use the standard deviation, which is why we go from x bar to the mu symbol. So we're going to look at a new normal curve, but instead this is the mu, this is the mean in the middle, this is the 1 z-score, 2 z-scores, 3 z-scores, this is -1, -2, -3. So there is a table in the back of your book that you will have to look things up on, and we will. So I will show you how to use the table in the class, but for now we're going to practice up here to find the z-score. So first of all, we're going to find it at the 65 inches tall. So 65, which is our x value they gave us, minus the mu, that's just your mean, divided by the standard deviation of 2.75. When I actually divide that through and simplify, I get 0.9 in the numerator, 2.75 in the denominator, and when I finish dividing it, I get 0.3. Now, when we look this up on the table in the book, we get a value. So there is a table. I will show you how to use the table when you're here. If you get the, I don't know, you could go ahead and look at it ahead of time. But we look up this value on our table, and it comes out to be 0.6179, which translates to 61.79%. And again, I will show you how to use the table while you're in class. Okay, I don't want to get too far ahead of it, but this, you look this up, this value on the z value or z-score table. Okay, so 0.3, that's like really close here. So we want the percent of women that are no more than that, so we want from this downward, 61.7%. All right, so now when it says to find the probability that a person is chosen between 60 and 63, so we first need to find the z-scores of 60 and 63. So 60 minus your 64.1 divided by the 2.75, and then we do 63 minus the 64.1 divided by the 2.75. And when we do our math, this gives us negative 1.5, and this one is negative 0.4. When we look them up on that z-score table, we end up with this decimal here. That's a 0.0668, which is 6.68%. And over here we get a 0.3446, which is 34.46%. Now, because we want to find the value between them, we're going to subtract. So we're going to say 0.3446 minus that 0.0668. Subtract your values to find the difference between them. We get 0.2778, which translates to 27.78%. So tomorrow, we're going to practice more with z-scores. We're going to look things up on the table and learn how to use that table in class.